Assalamualaikum warahmatullahi wabarakatuh and a very good morning. My name is Atika Binti Nihan. Today I would like to present about my journal is new azo derivative and their developed metal ion complex, synthesis, characterization and evolution of their antibacterial activity. The table of content in my assignment is first metal complex, second ligand, third preparation of metal complex, fourth microstate table, fifth Tanabe-Sugano diagram, sixth application. Okay, this is the structure of the metal complex. The complex name is 3,4,1H benzodiimidazole 2-il 4-hydroxybenzaldehyde dichloronickel 2. How we can get the oxidation number of +2? We can get the oxidation number +2 because the name of the structure, nickel plus ligand. The name of ligand 0 and plus -2 is dichloro. As we know, the charge of chloro is -1. So dichloro have a 2 atom, we times 2. So we get -2 and equal to 0 because the charge of the metal complex is 0. So we get +2. In metal complex, we use the azo ligand, which is 3,4,1H benzodiimidazole 2-il 4-hydroxybenzaldehyde. Let's look at the mechanism. This mechanism is how we can synthesize the ligand, how we can get the ligand. So let's focus on the structure and we can know how to produce the azo ligand. How to prepare the 3,4,1H benzodiimidazole 2-il 4-hydroxybenzaldehyde dichloronickel 2. How? The preparation of metal complex have 3 methods in the journal, which is synthesis ligand, determination of the possible structure of the complex, and synthesis of metal complex. Every step have their method, have their procedure when we want to get the metal complex. Microstate table. As we can see, the microstate table for the D8 electron configuration. Each column represents a possible value of ml. For the D8 configuration, ml can adopt values from -3 to +3. Each row represents possible ms value. For the D8 electron configuration, ms can vary between +1 and -1. +1 means both electrons have the spin of positive half. 0 means one electron has the spin of positive half and the other one has the spin negative half. The ms equal to -1 value is adopted when both electrons have the spin is negative half. How we want to predict how much microstate table we need to do? We can use the formula has been given. So in this case, I need to do 45 microstate table because it is the D8 electron configuration. After we complete the microstate table, we can define the term used in D8 electron configuration. In this case, we use the term of triplet F term because 2s plus 1 equal to 3 and L equal to 3 correspond to the term symbol F. This term is a triplet term. So the term is triplet F. For the Tanabe-Sugano diagram, Tanabe-Sugano diagram of D8 electron configuration in octahedral field have ground state as F term. In an octahedral field, an F term splits into three terms, A2G, T2G, and T1G. A2G is the lowest energy for the D8 electronic configuration. The difference in energy between the lowest energy terms A2G and T2G is equal to. In order to find, just can simply find the energy of the lowest energy transition in the absorption spectrum. The application of 3,4,1-H-benzo-diimidazole 2-il 4-hydroxybenzaldehyde dichloronickel 2. We focus on the biological activities on the azo ligands react with the metal ion, which is nickel 2. The metal complex has demonstrated that every substance that was examined possesses significant biological activity, act as concentration dependent manner. As a result, this metal complex may be employed as a medication to treat fungal and cancerous disorders following clinical studies. A recent study used various assays to design and categorize the efficacious antiviral medication which effectively treat COVID-19 by combining molecular docking with research using molecular dynamic simulations. We can better understand the ligand-protein interact. Azo ligands is 3,4,1-H-benzo diimidazole 2-il 4-hydroxybenzaldehyde can be developed to as therapeutic agents for bacterial infection.